SpaceWeatherExpert Team desde 2008 y ella tiene más que 150 publicaciones relacionadas a los temas de clima espacial. Doctora Larisa va a presentar en inglés, pero sus acetatos tienen tanto el texto en inglés como en español. En español está en azul, traducido con Google. Espero que se entiende. Para los que no hablan inglés tan fluente. Y bueno, doy la palabra a la doctora. Muchas gracias.
Good afternoon, everybody. I think it's you can hear it. I just don't want to shout too much. So I hope that you will have fun with my presentation, and I will start right now and without any much introduction. Storms in space, we will see what they are, and we will see what are the problems. Thanks to Google and Dr. Maria Sergeyeva for helping me with translation. So then we go as it goes, as it is historically has been done. So how people on Earth realize that space weather is something to do with themselves as well. Obviously, the first technology that has been introduced. Oh, by the way, Spanish is in blue, as you can see. So I put a lot of text, so it will be easier for you to understand if there is some problem with my English. Okay, that's now okay. So historically, people start to know that Earth is a big magnet and they can use it in their advantage and invent a compass. And as soon as they invent compass, they realize it's not everything is that clear with compass. And they start to realize it many centuries ago, before 1722, but only when people start to record it, that something is wrong. So that's we now know. In 1722, actually, watchmaker, not scientist, watchmaker, not scientist, noticed that magnet, the needle of the magnet had some variations, very rapid, and he was just wondering why. But then in 1744, he continued to study that, and with the help of scientists who was Celsius, you know this name very well. So they actually noticed that they have those irregular fluctuations during auroras. Then it follows further, and in mid-19th century, German explorer Alexander von Humboldt, he actually measured variations, and actually he was the first who gave them name magnetic storms. So next invention, great invention that people made, it was they realized that Earth is actually not only magnet, but also big electrical conductor, and they can use it. And they use it for electrical telegraph. So then the signal is, if this is pointer, oh yeah, okay. So then the signal goes from this point to this point over the big wire, long wire, and then goes through with Earth's return. So then they actually use not only wire, but also Earth as an electrical conductor. So, and approximately several years after invention, as soon as they start to use it widely, especially they put cable under the Atlantic Ocean, intercontinental. So then they use it widely, and after immediately after that, they figure out that there are some spontaneous currents which interfere with telegraph. And in 1847, I put here the citation from the gentleman who worked at telegraph. He said that when it was aurora, and then all the time when it was aurora, there were strong alternation deflection occur in all instrument on the telegraph, so on absolutely everything. And then it continues in more in years. You can see here the years, and it is not all that actually happened is recorded, because some people just experience inconveniences and did not have recordings. This is specifically a storm that I want to stop on. This is a superstorm which happened in August and September 1859. It names now Carrington event. It was really super. So since then, there were no comparable event yet. And obviously, people have a telegraph, and it was impacted. And there was a little problem with this storm, because it happened on the weekend. So then one day was not very well described, and another day was described. But for telegraph people who work 24/7, they noticed both of them. So one was in August 28, and another one, next one, was on September 2nd. So, and you can see that this is evidence from Europe. And this is not particular high latitude. It's quite mid-latitude locations. People were not really experienced before too much with that, but this was really observations done by person who worked with telegraph at that time. That event attracted a lot of attention by scientists, so much so that they actually later they published, this is publication, they published special issues of different journals. And this map I pull out from this publication, and this is aurora observation on September 2. So, and if you can see in North America, you can see that it was quite a lot of aurora seen even in Mexico. At the same time, astronomer Richard Carrington. So then now we know that that all the time we have some problems. We have auroras, but finally Richard Carrington, he was monitoring the sun. He was astronomer, and on September 1st he saw a very large sunspot group. This is actually his drawings. So he saw this large sunspot group, and on September 1st, he saw a blast of white light at the surface. These blasts or eruptions, now called solar flares. So he was actually the first one who connect problems on Earth with some events on the sun. Another very important, especially for Canada, event was in 1989. So, but before going to, again, I lost this pointer. Okay, before pointer. Okay, it works. Before going to 1989, I want you to look at the citation at the top. Citation at the top was connected with the fact that development of telegraph, telephone, cable, and other application of electricity, the more development mankind do, the magnetic storms disturb more and more. So then, and actually it has been pointed at 1903. In 1903, people already know that the more development mankind is doing, the people are doing for their technology and so on, they should pay attention to the magnetic storm and other accompaniment or other sources. So with the power grids and the power systems, the first, it was reported in March 24 magnetic storm, 22 companies in Canada and US. And then there were reports from 46, 57, 58, 60, 72. Nevertheless, when it happened to be March 89, and this picture, again, so this picture that you see, this is on the horizontal axis. This is the year, and the light white is sunspot numbers. As you know now that Carrington has mentioned that these events are actually connected to sunspots, and the dots on the top is the events which happened on Earth, events on different electrical system. So now we go to next event which happened 1989. But I wanted to make sure that you understand. People know about electrical systems, including power systems, since 1940. Nevertheless, in 1989, it was time when it was great magnetic storms. This yellow stuff is variations of magnetic storm, and the red arrows is actually identify when happened to be problems. So, and Hydro-Quebec power systems lost the power for 9 hours. Whole Quebec system. It is very big. Whole Quebec system. It is a very big system. I will show you map a bit later. So it is a very big system which for 9 hours no power. Besides, they know since 1940 there might be problem with magnetic storms. So this is power systems, and if you can see scale here, it's on the right side. On the right branch, you see that it is one part is 600 kilometers, another part is another 100 kilometers, 1,000 kilometers top to bottom. So it's very big, covering. On the top there are some dump and which generate electricity, and on the bottom is Montreal, the biggest city in Quebec province, which actually consumes the energy. What happened is happened in few minutes or seconds. So then as soon as magnetic storm started, so one standard watt compensation tripped, so then it more and more and more and more and more. So then transformer damage, and in 90 seconds, grid has collapsed. Darkness. Okay, so next, or maybe the day after next, it was in newspapers. We have this recording, this photos of newspapers. If you see this woman, it is actually, she is brewing coffee. This is coffee maker in a candlelight. So then the famous Quebec start to be famous, and so on and so forth. And before that, Quebec Hydro-Quebec system was very famous negatively because it has there was problems all the time. As soon as it is rain or storm or whatever, the power failed. So then they did not believe it is because of magnetic storms. So public and newspapers said that they blame that it is sun, that as if it is not their fault. So Hydro-Quebec power system collapsed. What are indirect impacts? So it was steel production in Quebec. It stops. Zinc production, it stops. Aluminum production, it stops. Pulp and paper, no. Milk production, no. Car assembly, no. So then they shut down automatic bank machines and bank branches, and even the stock market was also in difficulties and troubles. And last but not least, because Hydro-Quebec has, sorry, not Hydro-Quebec, but Quebec has Molson Canadian beer. So then beer stops produced, a lot of impacts. So now we know that Earth is big magnet. Earth is also electrical conductor. What else has Earth that make troubles to people, but actually make advantages? So people start to use ionosphere. And in plain words, it is conductive shell above the atmosphere. And it is used for long distance radio communication. I'm not getting into technical details, although this picture is quite technical. It shows that it has several layers. And so then when you start to actually have some waves, so then they bend by ionospheric conductor, so then radio wave bend, so then you cannot directly talk to people, but you can indirect, and so then this names communication over the horizon. So, and apart from good, there also start to be troubles. So in 1928, people start to figure out that it was actually not only good, but sometimes it was loss of radio signals, and practically always it's again, it coincides with appearance of large sunspots, blame sun, and intense aurora, blame ionosphere for that. So this is Marconi, who actually was pioneer with this communication, radio communications. So, and it's going on and going on. And in in some years, and so Edward Appleton, who was Nobel laureate in 1947, he actually addressed the need to forecast of what he might call ionospheric weather. So, and his phrase ionospheric weather, it actually was precursor of space weather, because it's not only ionosphere, as you now know, it's also sun also to blame for that. So this is a citation from him, and this is the paper which I put it all off. So it's not all my only. So, and what is space weather? So space weather is all the phenomena which start from disturbances on the sun, propagate through interplanetary medium. You know, from sun to Earth, it's one astronomical unit, so it's quite astronomical scale. So, and include impacts on near Earth space and geophysical consequences. So here is schematics of what it is from sun to down to Earth. It goes through several areas which has their own name, like magnetosphere, ionosphere, and finally Earth. And these are impacts. So it obviously impact satellites and impact also if you have people on this, International Space Station, power and communication, and aviation, because they use communication a lot. Next slide. So now a little bit of boring stuff, which is definitions. And those are actually, those images are taken from Solar and Heliospheric Observatory observations. Everybody can go on the website and look at those. It's free, available to whatever. So these are pictures of taken real pictures. So taken from satellite, which actually facing the Earth. And these are pictures of flare and solar flare, and this is definition. So this is picture of sudden coronal mass ejection, which is also has definition. And this is also what goes together with this, all these eruptions, is actually solar energetic particles, which actually damage satellite. And here you see snow, like snow, and it is what the satellite has been damaged. Actually, you see the snow, its particles hit the satellite field of view. Apart from those three eruptive events, so they also kind of like some features on the sun which rotates together with the sun, like coronal holes, and produce some very high speed particles which goes. And also, as you know now, you have sunspots and dark spots. Those are also photos. So then this everything is available online. This all these first three top pictures is actually correspond to the same event, which also has a lot of impacts. So apart from that, what is actually interplanetary? This is schematic of sun and schematic of Earth and the bubble around Earth, which actually created by solar wind. I like this name, solar wind. The wind from the sun, which is streamed all the time. It's forever. So, and actually it's shaped the Earth's magnetic field, so it's not quite symmetrical. So it's actually a bit squeezed on the facing sun part and extended. This squeezed is this bubble shape called whatever inside called magnetosphere. That's actually defined mostly by Earth's environment and by Earth's magnetic field. What is outside is defined by sun magnetic field. Inside the magnetosphere, there are areas which names radiation belts, where charged particles sits all the time, and it poses a danger to satellites which are here, and that's closer to the Earth. And even more closer to the Earth is ionosphere. And this is actually this is not a picture. These are just drawings, so that they are not to the scale. And this is not how ionosphere looks like. You cannot picture it. So, but as you can see, it's 52,000 kilometers. So geomagnetic storm, you cannot picture geomagnetic storm unless you measure magnetic field. So that's why it is just a line. This is how it is when it is quiet, and this is how it is when it is storm, and that it is again quiet. Now I want to show movie. And I don't know who will help. The green one, please, first. So now we see event, just loop it, I will continue to talk. So we see flares like that. This is flare. You see a flare, and then you will see some maybe more flares, but you can see these bright areas. They name it active region. You have all the problem coming from those active regions. And this is more bright. And this is famous Halloween storm event. It was kind of like a gift given by the sun to actually American Space Weather Forecast Center, because it was happening at the time when American government was about to reduce the funding of Space Weather Forecast Center, but because it was at the same time as event happened, they changed their opinion. So, and next this is flare, and now you will have coronal mass ejection. And you see the snow, the satellite has been a little bit damaged, but it recovers. So those are blasts which goes off the circle. In between, those are coronal mass ejections. So why coronal? Because they seen in upper atmosphere of the sun, which names corona. Why you have this this circle? Could you please go back to the red movie? So why you have a circle? It is because the sun is so bright that you cannot see corona. You saw this big blast like a loop. So you cannot see corona unless you cover the sun. So it's kind of solar eclipse artificially created on one of the instruments which flies on in space. So then it means that when it is solar eclipse, you can see corona. And if you're lucky and everything coincides, you might see even some ejection. So next slide. Okay, so I should be able to do that. Yeah. So this is a little bit more about this event which we just saw. So then flares. So 17 flares during this period, and flares are in scale of actually X flare, which is X17, which shows over there. It is above the largest, so because X is extreme and it is in logarithmic scale up to 10, so 17 is above 10. So and another one was on November 4, when the active region was already on the solar limb, so it does not reach us, but actually it hits satellite. So, and actually it has been estimated, because it hits satellite, it saturates the measuring instrument. So, and it has been extrapolated as a X45. So it's 4 times more than largest, which is there. So Aurora was seen even near Houston, Texas. This is Texas. This is red aurora, because in low latitude you mostly would see red auroras unless you have Carrington-like event. So impacts. Geomagnetic activity has been increased during 12 days with 2 severe storms. So auroras seen as California and Houston and Florida. So impacts. So then at that time, power systems were already prepared. They learned lessons. So very short power blackout happened in Sweden in a very small city. So it was not really a big deal. So in communication, again, the people cannot can switch to different radio wave frequencies, but there was quite a lot of problem with communication. Sorry, I was thinking that should be some translation there. Anyway, so it was impact on communication, and there was a lot of scientists in Antarctica, as you can imagine. So then they have experienced 130 hours without communication, which for Antarctica is critical. So satellites, at that time in 2003, there were plenty of satellites, and the effects on satellites are numerous. So obviously they are first system which experience all the space weather effects. So then there were many operation anomalies during this Halloween event. So, and to the point that Japanese space agency lost satellite completely. I mean, it was piece of garbage flying there. And this is actually citation from their communication with SWIPC. I have these citations from NOAA, from US report. So, and they present this. So then the Japanese done everything possible, and they kind of like ask to excuse that the satellite has been lost. And as you can imagine, how many equipment there are on satellites, all the imagers for science, for weather, for everything, it has been lost. At that time, at a station, it was also a problem at space station. So now, really modern days. So for aviation, communication problems and navigation problems. Here is when magnetic storm hit, and here is problems with the signal, GNSS signal. I will go fast because it's already time, but presentation would be available from America and Maria. So then navigation over the polar, especially sensitive to communication problem, but also other things. And you will see, so now it is in Spanish for you to read a little bit. So now this is even more modern. It is 2015. And it was not very big event. It was solar flare, but not extreme. But the problem was that it was radar system on radar system which helps to land airplane on aerodrome, on airports. And so then that radio system, that radar system actually happened to look directly into the sun when it was flare and it was low in horizon. So that coincidence of these things, and people who forgot that it might be some problem with the sun, so actually end up with having the problem to land airplanes and some things. And the next is actually the bottom one is again, so it was not very big solar event. It was just set of major, it's some of a set of not even major flares. It was only one. But the problem was that at the same time, it was several hurricanes, and it was hurricane season, and many emergency communications use exactly the same frequencies, which actually happen to be affected and corrupted by this solar flare. So then you can see that there were really not very happy coincidence, but people should be aware that it might happen. If it happens once, it might happen again. And everybody knows about SpaceX Starlink satellites. So then again, February 3 and 4, it is absolutely modest geomagnetic. So if you can see this line, it was a little bit over here and a little bit squiggle here. But at that time, they experienced problems. And by that time, they were much less, it's actually out of 49 Starlink, 38 were disappearing. And this is actually a picture on the top. On the right side, you see this white things. It's a picture of a Starlink which goes down and burn in the atmosphere. Again, so as you see on the right hand side, there is explanation that at low orbit you have atmospheric drag. During magnetic storms, atmosphere expand in the higher altitude up to ionosphere. So then the denser, so then more drag, and so then satellites did not sustain it. So now they changed the actually procedure where they park satellites. So they park them not 200 but at 300, and because you need more different rockets, different fuels, so then there are less satellites. And space weather observations, there are a lot of observations from the ground, which are absolutely important, and from magnetic ionosphere solar observations, because it is much cheaper to have observations on the ground, local to the where space weather effects happened, rather than launch the satellite, which are absolutely important as well, because you can measure on satellite something that you cannot measure from the ground. So here I only want to compare. So we have 148 millions of kilometers from sun to Earth, and we have plenty of satellites, it looks like, but it is only one point. It doesn't cover anywhere else. So these are satellites which sits at the same practically point. So they all sit and actually look at the sun. So and then we have 600,000 to the Earth, and there are more satellites here, and especially geostationary, which also measure some solar stuff. But I can tell you that's much less covered than Earth observations. Now, what happened with space weather? For flare, to see effect of the solar flare, you need 8 minutes. So by the time you see the flare on goes, it is already here. You cannot do anything. You cannot predict it. So by the time you measure it, it's yours. So solar particles, you have from minutes to hours. Maybe you can be prepared. So then coronal mass ejection, which cause magnetic storms, you have few days to be prepared. And there are also some recurrent activities at the bottom. So in these conditions, forecast is very difficult. Nevertheless, there are brave people who dare to forecast it. And I can tell you from my 22 years of experience to be in with space weather forecast, this is absolutely exciting stuff, because you don't have chance for mistakes, but you cannot, some things you cannot do. It's like flare, you cannot predict, but people need to know flare because they have many impacts. Among those brave people, Mexico is not lost. So, and people from Mexico are here. So what else I had to say? In summary, so space weather can damage or disrupt everything. All these vital and first importance technology systems, they are critical. Spaceborne critical, airborne are critical, ground-based are critical, especially now when you have interdependencies of critical infrastructure. When you damage power systems, you damage everything, absolutely. So that's so many connections. And you have increased satellite services for many things which become critical as well. These are, again, one more picture from Lanzarote, what is actually impacted. And this is, you know, who think about GNSS services 20 years ago? Nobody, but we have GNSS now, and we have impacts on GNSS. So I would like to say thank you, and here is my thanks to the organization which invited me here, and to Dr. America Gonzalez and Dr. Maria Sergeyeva. Thank you.
Preguntas.
Larisa, welcome to Mexico. We are very happy to hear your talk. And I wonder if you could tell us a little bit more about the importance of the international collaboration for space weather observation and forecasting, and in particular, why for Mexico it is important to have our own monitoring system, our own instruments.
It's easy. If you look at the map, you know where Mexico locates, so you know how good it covered with space weather instruments on the Earth. Space weather impact are very local. Geomagnetic field here is not the same as there. So if you have here some big squiggle, you don't have it over there. So then, if you want actually systems in Mexico to be aware of space weather, you have to have it local for sure. That's one thing, because it is different. It is different from Australia. It's different from Japan and so on. Why it is internationally important to collaborate? Neither Canada nor Mexico, we don't have satellites. Satellites give us a little bit more on what to expect. So satellites are important. So, but we all use satellites which no US actually put on space, and Europe put on space, and so then all 22 centers which exist. So, but don't diminish the ground. It's even more important. Yeah, thank you. I hope I answer your question. Yeah.
Hi, Larisa. Thank you for your presentation. And so, as far as I understood, the Carrington event is the largest one in the history.
Yep.
So, and we know that we are very, I mean, our infrastructure, telecommunication, etc., it's very fragile. So, what do you think it could happen in case some event like the Carrington one happens in the future, in the close future?
We're going to survive. We're going to survive. Now, first of all, we are more vulnerable to space weather because we have a lot of industry which actually have this impact. But we have a lot of knowledge that it might happen. So in terms of power grids, they have special operational procedure for sure. I work with them closely. I know that they are very careful about that. So they will shut whenever it is needed. They will go to different things. They have their measurement. In terms of communication, that's actually America knows more because they have a lot of things which measure communication quality over Mexico. But I can tell you that if ionosphere is blocked for some frequencies, it might be changed in the frequency. It's important to know what exactly happened at that, so then they switch to another. So that for sure we will suffer, but we will survive, and we now know much more about space weather than at that time, despite the fact that we have more systems. So, but we need to rely on, we need to have observations, we need to have forecasts, we need to develop these things.
Thank you so much.
Dr. Larisa, thank you so much for your presentation. Last year, we got a couple of G9 geostorms that allowed northern part of Mexico to get some auroras. What are the chances of getting in the next couple of decades a storm like the Carrington event, and are we gonna be able to face a superstorm in the future like the one that happened in 1859?
I'm not quite sure. So it's about Carrington event. Will we struggle through that? If it is Carrington event, we will be affected. If it is about aurora, so hopefully you will see not only red aurora, because red aurora can be seen in low latitude. Did I answer your question, or I didn't quite catch the?
Like,
could you, Maria? Could you help me with?
What are the chances of getting a superstorm in the future?
I can tell you that solar activity in terms in long things, if you have 1 in 100 years event, it doesn't mean that you will wait 100 years to get it. It means it's just happened that often in statistical, but it can happen tomorrow. Currently we are in a little bit more over the maximum solar cycle and going a little bit down. I personally don't see hints that we will have Carrington, but next rotation we might have this sunspot, and we will all watch and see like it was in 2003. So we watch was kind of like open eyes how the sunspot rotate and become grow, and everybody can watch it because that sources are available now, not like in Carrington time. So we all watch and we will expect or not expect something happened. What will happen with Mexico? You are on top of science, so you're on top on the forecast. I would say that you will be prepared.
Thank you.
¿Más preguntas?
Bueno, muchas gracias por sus preguntas, muchas gracias por su atención y agradecemos a la doctora Larisa Trichtchenko por esta plenaria.
Just to conclude, that's a work that I love very much all my life. So then if you have questions, I'm here tomorrow, so you can see me in somewhere. So then don't hesitate. Besides, I'm very welcome email connections, so everything is, so then, yeah, thank you very much for such a warm invitation. Thank you.
Muchas gracias.